Welcome, everyone. My name is Gavin Claus with LogiStar Solutions. I'll be your host for today. Today's presentation is part 2 of our ongoing webinar series for SAP Warehouse Management and Extended Warehouse Management. Today, we'll be taking a comprehensive look at outbound processes for warehouse management and extended warehouse management and providing comparison of the functionality. For those of you who have missed the last presentation, the presentations are available on our website, which is www.logi-star.com. And the next webinars coming up in our series will be a case study on Harry and David, which is a review of their decision to implement extended warehouse management, and we'll be discussing their project experience so far to date. And then the following webinar will be on parcel shipping within SAP, leveraging the XPS cross-carrier packing and shipping solution built into SAP. To cover some housekeeping items, in the beginning of the presentation, we'll go through a high-level overview of LogiStar Solutions. And then I'm going to hand over the microphone to Doug Scott, a Senior Warehouse Management Consultant with LogiStar. During the presentation, I encourage you to please submit any questions into the chat. And at the end of the presentation, we will get to those questions and provide you with some answers. If we do run out of time, please feel free to continue to send questions or send them to info@logi-star.com. And the email will be provided on the last slide, and we'll follow up with you and get you some answers there. In addition to questions, we will be sending out an email with a survey on the presentation. What we're looking for is hopefully get some candid feedback from you on the presentation. Make sure that we're providing valuable content, and so we can improve upon our webinars in the future. So let's get started. In the presentation here, I want to discuss a high-level overview of LogiStar services. We are essentially a boutique consulting firm with extremely deep experience in extended warehouse management and warehouse management. This is validated by both our customers as well as SAP, as you can see, with our many credentials, including some exclusive designations such as our rapid deployment solution status. Being solution-focused, we are involved with many different industries and companies, basically anyone that really moves product from point A to point B. With that, we work with many industries, some being very higher volume, more complex industries such as retail and wholesale distribution. As we are laser focused on warehouse management, we basically work with many services and products that tie into SAP EWM. On the upper left-hand side of the screen, you'll see RF and barcoding, as well as voice picking. So kind of the data collection elements of a warehouse management system, leveraging some of SAP's native solutions, such as SAP Console and ITS Mobile, as well as a voice picking application that we've developed that integrates to the SAP Console and ITS Mobile technologies to enable voice-enabled picking and processes throughout the warehouse. Also tied into warehouse management is the shipping side of things, where we work with our small parcel shipping solution called XPS that's built into SAP for shipping small parcels such as UPS and FedEx, as well as doing some of the LTL execution and full truckload execution. Transportation management is SAP's transportation management solution, which is really the more comprehensive solution that includes more ocean freight and full truckload solutions, and is currently in their release of 8.0 at this time. On the bottom left, again tied into warehouse management solutions, specifically around EWM, is some of the more advanced reporting capabilities, including SAP's labor management solution, and some of the additional applications that are available for labor analytics and warehouse cockpits and monitors. Being a turnkey solution provider, many times with our customers, we're starting off in the beginning of the implementation cycle and really building the supply chain strategy and understanding the fit for some of these solutions such as WM and EWM, doing a comparison and identifying which is the right solution for your operating environment, and defining the overall solution architecture for your enterprise. So that may be looking at different solutions for your manufacturing operations versus your distribution operations, and building a roadmap for you to deploy these solutions moving forward. So with that, I'd like to hand over the microphone to Doug Scott, who will take us through outbound processes for warehouse management and extended warehouse management.
Okay, thank you, Gavin. This is Doug Scott speaking. I'm a senior WM consultant with Logistar, and welcome to the webinar today. As Gavin mentioned, this is the second one in a series of Logistar webinars. I think many of the people on the call today were also present for the first webinar, which focused on inbound processing. So some of the material in today's presentation might look similar to what we covered in the first webinar, so to those of you who are joining us for a second time. So this is our agenda for today. We're going to start with an overview of the outbound processes as they're supported in the ERP, WM, and extended WM solutions. And we'll highlight some of the differences between the two systems. We'll look at some of the core functionality provided in EWM for the outbound process, such as picking, packing, and loading, followed by a little demonstration of some of this core functionality. Then we'll take a quick look at some of the additional advanced functionality supported by EWM that can be optionally worked into your outbound process. And we're going to take some time at the end of the webinar for some questions and answers. So let's begin with a brief comparison of the two warehouse management solutions offered by SAP. The extended warehouse management solution is a component of SAP's supply chain management application suite and was first released by SAP in 2006. The ERP WM solution is the traditional WMS that's been included in SAP's ERP software since the 1990s. So this is the outbound process that's supported by the ERP warehouse management system. It's a fairly simple flow involving a simple transfer order to help us plan and execute the removal of materials from warehouse storage bins against an outbound delivery. ERP WM provides a basic picking process that serves the needs of many straightforward warehousing operations. Additional functionalities can be implemented in ERP WM utilizing add-ons and user exits and various customizations. For example, the loading of materials onto outbound vehicles is possible if you use the yard management component of the logistics execution system in SAP. With extended warehouse management, we're able to model a more complex outbound process. If you require value-added services, such as labeling or kitting, to be carried out in the warehouse on picked materials, these activities can be built right into the process and executed in the system. And the yard management structure and capabilities, such as loading and tracking of outbound vehicles, are built right into the EWM system. You don't have to use a separate application component. This slide highlights some of the key differences between EWM and ERP WM in relation to the outbound process. First of all, the EWM system gives you much greater flexibility in your process design with standard configuration settings. For example, you can configure more complex picking strategies. You can perform kitting activities in a kit-to-order scenario. EWM offers a more robust technique for managing picking waves, which can help you manage and plan the warehouse workload. Picker-directed replenishment can be included as part of the outbound process as well. And also the functionality for yard management, cross-docking, task and resource management, and value-added services are completely supported within EWM without the need for any extension sets from SAP. Just continuing on this theme, EWM has the ability to connect directly to and control the activities of your external systems, such as ASRS and conveyor systems. This is done using the EWM Material Flow System, or MFS, which sends warehouse tasks to the Programmable Logic Controllers, or PLCs, in your external system and receives confirmations back on those tasks from the controllers. This is in comparison to the ALE and IDOC type of interface, which has been and still is supported by the ERP WM system. EWM has built-in labor management capability for tracking and evaluating labor costs and effectiveness, which is not available in ERP WM. There are multiple cross-docking methods that can be implemented in EWM, and those are listed here on this slide. EWM provides a new monitoring functionality not available in the ERP WM system. The Warehouse Management Monitor is a transaction that can be tailored to match your own specific warehouse environment, and you use it to monitor the status of all your warehouse documents and activities. And finally, EWM was designed by SAP to be suitable for high-volume distribution centers, more so than the ERP WM system. This next slide highlights some high-level differences between EWM and ERP WM with regards to deployment options, master data, and warehouse structure. Since EWM is not part of the standard ERP software, there are several options available for deploying it in your system's landscape. You can have it installed as an add-on within your existing ERP system, along with some related basis components from the SCM software. Or you can have it installed on a separate dedicated SCM server. As you'll see in the demonstration in a few minutes, deliveries that are created within the ERP system are interfaced, transmitted to the EWM system. In terms of master data, much of the relevant master data needed to process activities in EWM is replicated from the ERP system to EWM. For example, the ERP material master data is replicated to the EWM system and becomes warehouse product master data. Vendors, customers, and batches are other examples of ERP master data that need to be replicated to EWM. In terms of the warehouse structure, all the elements of the ERP WM organizational structure are present in EWM, such as storage type, warehouse number, and storage bin, but with some additions and some changes. For example, the storage type can now contain up to 4 characters in EWM instead of 3, and the storage bin number can contain up to 18 characters instead of 10. Storage bins can be grouped into activity areas for the purposes of optimizing your routing of tasks for putaways, picking, and so on within the warehouse. And finally, storage types can be defined in EWM to represent staging areas, work centers, yards, doors, and so on. Now we're going to move on to the next section and review the core functionality provided in EWM for the outbound process. So this is an overview of what I'll be showing you in the next set of slides. We're going to look at a few process flow diagrams that describe the outbound process. We'll review the stock removal strategies that are available in EWM. I'll describe the usage of warehouse tasks and warehouse orders and the concept of storage control. And also we'll look at wave management, picking, packing, and loading and goods issue. This is a document flow diagram that shows the various document types in the standard EWM outbound process. The key document types here are the sales order and outbound delivery in the ERP system, and an outbound delivery request, outbound delivery order, and outbound delivery in the EWM system, as well as warehouse tasks. So the process begins with a sales order, in the ERP system. And note that this could also be a stock transport purchase order from the materials management system. We create an outbound delivery document in the ERP system from those source documents. Then the ODR, or outbound delivery request in EWM, is just a replication of the ERP outbound delivery in the EWM system. So the data in the ODR is checked by EWM for completeness and consistency. And as long as it passes these checks, then an EWM ODO document, or outbound delivery order, can be activated. The ODO is the real working document in EWM against which we can record the completion of various warehouse activities. We create and confirm warehouse tasks against these deliveries. Something not shown in the diagram, warehouse tasks are always grouped into warehouse orders. And a warehouse order is simply a work package for a user to carry out. It's put together by the system according to pre-configured rules and filters. And finally, upon completion of the ODO, the EWM system generates an outbound delivery document, which is used to communicate back the completed information to the ERP system. You'll notice that this slide doesn't mention transfer orders. Transfer order is a WM term, not carried over from WM into EWM. This is a simplified business process view of a typical outbound process that can be modeled in SAP EWM. Your process may include any or all of these steps, and there are a number of standard EWM radio frequency transactions available to support all of the steps to be executed by warehouse users on mobile devices. Now we're just going to look at some stock removal strategies. A fundamental part of the outbound process, of course, is the selection of stock from storage bins for picking against outbound deliveries. SAP EWM supports the strategies that are listed here. They're the same strategies that are provided for in the ERP WM system. However, the means by which they're implemented are significantly different in EWM. In WM and the ERP side, the available strategies are sort of hardwired to use certain parameters in order to achieve the various strategies, and as such, they're rather static in nature. With the exception of stringent FIFO, it's just a matter of choosing the best strategy to apply to each individual storage type. In EWM, on the other hand, you're given a catalog of available attributes to choose from, and you can build your own removal rules using any combination of those attributes. So you can make up removal strategies that are as simple or as complicated as you want. For example, you could set up a first-in, first-out strategy that also considers the country of origin using the goods receipt date and country of origin attributes. So this is a significant advantage that EWM provides over the ERP WM system. EWM also provides 10 business add-ins, or baddies, which you can use to further customize your removal strategy. In one of our earlier slides, we mentioned the creation of EWM warehouse tasks and warehouse orders with reference to outbound delivery order documents. These document types are the executable warehouse floor level documents in the EWM system, and there are a number of techniques that we can use to create them to optimize the efficiency of your operation. A warehouse task typically requires some quantity of a material to be moved, and it contains data that identifies the material, such as a product number, possibly a batch number, as well as the quantity and information on the source and destination locations. Warehouse task may also be for an entire handling unit, such that all the materials contained in the handling unit are moved together. A warehouse order is a grouping of warehouse tasks and is assigned to a specific resource for execution. It's a work package, and it's meant to be carried out by one person. Warehouse orders are created according to task sorting and filtering rules, which you have to configure in EWM to suit your business requirements. Next up is the concept of storage control in EWM. Storage control allows multi-step processes to be defined in EWM. We'll take a closer look at this in the next couple of slides in relation to the outbound process. So basically there are two types of storage control, process-oriented and layout-oriented storage control. Process-oriented storage control considers the attributes of your different materials to determine an appropriate sequence of process steps. Layout-oriented storage control, on the other hand, considers the limitations of your warehouse layout to determine how materials need to be moved to achieve a specific stock transfer. The outbound process can also be defined using a combination of process-oriented and layout-oriented storage control. In process-oriented storage control, different materials are handled with different process steps. The outbound material, represented by the blue triangles along the top of this diagram, is packed at a packing station and then forwarded to a second area for load preparation. Then it's placed into an outbound staging area for loading onto an outbound vehicle. The path at the bottom of the diagram shows a different material being picked directly from a forward pick area into the outbound staging area. So again, it's the nature of the different materials that's driving the decision to use one of these two different process flows. This slide, on the other hand, is showing a layout-oriented storage control, where the EWM system recognizes that a transfer of outbound materials from the high rack storage area first requires a movement to a pick point. So the pick point is defined in EWM as a storage type. And so in this case, there are two moves that need to be executed. With process-oriented storage control, as I've said before, EWM gives us the ability to support complex outbound scenarios. And these are the types of steps we can link together in a sequence. We'll look at these in the next sequence of slides: picking, value-added services, kitting, packing, staging, and loading. Picking, of course, is the removal of items from storage bins to fulfill outbound order requirements. You might also need a picking process to support the provision of materials to a manufacturing area. In EWM, the system helps you to prepare picking tasks from outbound delivery order items using removal rules and storage type searches. And the tasks are organized into warehouse orders using predefined filtering and sorting rules. At this point, the system also assigns the orders to RFQs and resources, and the pick path through the warehouse is optimized and determined as well. We might also want to organize the picking tasks into waves. We can then execute or confirm the picks using EWM desktop screens, or we can do it on RF. Using the RF screens, we have the option of selecting the orders by order number, or by using a system-guided selection. The standard RF screens in EWM include verification fields so that users are forced to scan certain barcodes to validate that they're picking the right material from the right locations, for example. EWM has functionality for pick denial, which is appropriate when you're faced with not being able to pick the needed material for some reason. And when you use this function, you can initiate a replenishment to the bin, for example, if the bin has become unexpectedly empty. That's known as picker-directed replenishment. And also, we have the ability to reverse a pick that was previously completed, and this is known as pick cancellation. EWM features a wave management capability that's different from what we have in ERP WM, in that you can assign picking items into different waves from the same outbound delivery. It does this assignment using common attributes such as picking area, the method of picking, and so on. And this is in contrast to WM, where all the items from outbound delivery have to be assigned to the same wave. You can create waves manually using this wave management screen in EWM, or you can set up wave templates and schedule jobs to automatically group open delivery items together into picking waves. You can also use this wave management screen to release, split, merge, lock, or unlock picking waves. You can also freely remove or add picking items to waves before you release them. Value-added services. We can build in one or more value-added services or VAS steps into the outbound process. Some examples of VAS activities could be assembling, labeling, or tagging of materials. And in EWM, we use a VAS order to capture the details. We can collect data on the time spent on the activity. We can consume any auxiliary materials that were used up during the execution of the order. And we can also record additional time and effort spent on the order. The creation of a VAS order requires specific data to be maintained in the product master, as well as packaging specifications master data. And the system uses the condition technique to determine which VAS activities are relevant to the material. There's a user interface in the EWM system that we use to execute a VAS step. And once we mark it as complete, the system can be set up to automatically generate a subsequent warehouse task for another value-added service step, or for packing or loading. Kitting, this is the assembly of two or more component materials into a single item, such that the component materials are picked and combined into the final material, which is then shipped out. EWM supports both kit-to-stock and kit-to-order scenarios, as well as reverse kitting. So in this discussion of the outbound process, it's the kit-to-order scenario that's relevant. The basic requirement for carrying out kit-to-order kitting is the creation of a sales bill of material in the ERP system. This allows outbound deliveries to be created in the ERP system with the kit header and kit component materials included. And these deliveries are interfaced to EWM, where we can manage them as outbound delivery orders. In EWM, we have 3 different ways of executing a kit-to-order outbound delivery order. We can execute the kitting as a value-added service with a VAS order at a VAS work center. This would be appropriate if you have the need to record the start and finish time for each kit assembly, or if you have additional VAS elements like auxiliary materials and effort tracking that are part of the kit assembly. We could also execute kitting without a VAS order at a generic packing work center, and this would make sense if you have a kit assembly area, but you don't really need to keep track of VAS-related details. And thirdly, you can set it up so that the kits are actually assembled during the picking activity, where components are simply picked into a pick handling unit, and the assembly is completed by the order picker during the confirmation of the picks. Now in EWM, there are a couple of ways in which we can record the packing of picked items. We can have the system automatically create suitable pick handling units so that the items are picked directly into the containers in which they will be packed. This makes sense when items are ready to be labeled and shipped as soon as you pick them off the shelf. Or we can transfer the picked materials to a separate packing work center where packing is recorded using a work center user interface. And on this slide, I'm showing the desktop packing screen. You can create handling units in this screen to represent the cartons and pallets into which the picked items need to be packed. And you can drag and drop the picked items into the packaging materials. You can also trigger the printing of related documents, such as shipping labels and packing lists from here. These packing steps can also be recorded on an RF device. There are reduced size RF screens that support all of these functions being carried out on a handheld or vehicle-mounted RF terminal. Multi-level packing, for example, the packing of cartons onto pallets is also supported. Staging is simply the transfer of materials that have been picked and possibly packed to a staging area prior to being loaded onto an outbound vehicle. There could be numerous staging areas in your warehouse, so the selection of the staging area to use is typically automated at the completion of the prior task. The staging area is where the final preparation of the staged orders takes place. And in the loading activity, we record the details of what is actually being loaded into trailers or other transport containers. The loading activities can be planned using an EWM desktop user interface, or it can be done manually using RF screens. As well, EWM is flexible enough to allow you to perform either simple loading, which is simply adds a timestamp and updates the status on the outbound delivery order to indicate loading has been completed, or complex loading, which more closely models the actual loading of handling units onto trailers. And goods issue is the last step in the outbound process, and we have several options available to post the shipments from the warehouse. Typically, you have the system set up to post goods issue automatically upon completion of the loading activity. But you can also post deliveries individually or from a list, or even upon checkout of the vehicle or trailer if you're using the yard management functionality. Also, EWM supports partial goods issue. For example, if your shipment gets loaded onto more than one vehicle, you can post multiple goods issues as the vehicles leave your loading dock. In EWM, we also have the capability to generate a customer invoice prior to posting goods issue, which is sometimes necessary, for example, if you need to generate invoices for customs processing. And finally, you can use freight order management functionality to group together multiple outbound delivery orders having the same source and destination locations into shipments. And for these shipments, you can transmit information to freight forwarders and print appropriate paperwork, such as bill of lading for the entire shipment. Next on the agenda is a demonstration of the EWM outbound process, and I'll be showing you a sequence of EWM screens that illustrate the actual processing of an outbound shipment within the warehouse. This will include some EWM yard management functionality so that we can record the shipping activities related to an outbound trailer. So this is the scope of the demonstration. We're going to see an outbound delivery order and warehouse tasks created in the EWM system, and we'll enter the pick and pack execution as we go along. We'll do some yard management functions and the posting of goods issue. And I'll be using the standard RF screens provided in EWM for some of these activities. This picture is just a graphical representation of the scope of the demonstration. As you can see, the yard management transactions can be done, a lot of them can be done in parallel to the warehouse transactions, although I need to show them sequentially in the demo. So the process always begins with an outbound delivery in the ERP system. So this could be a delivery for a sales order in the sales and distribution module, as we're showing here, or it could be a stock transport order from the materials management side. When the ERP outbound delivery is saved, it is distributed automatically to the EWM system using a queued remote function call, or QRFC technique. This is the ODR, the outbound delivery request in the EWM system, which is the result of the distribution of the ERP delivery to EWM. Note that the document number is the same as the ERP delivery number. So this is merely a replication of the ERP delivery in EWM. So here it gets checked for completeness and consistency. If any errors were found at this point, it would have a red status, and we'd have to make corrections before continuing on. However, everything is green here, so we can keep going. This is the outbound delivery order, or ODO, in the EWM system. The system activated this ODO automatically when the ODR was created because there were no problems with the delivery data sent over from the ERP side. You can see that the picking status, packing status, loading status, goods issue status, these are all sitting at not started. You can see that the ODO document number, which has been internally assigned from a number range, is 6313. And this document will be updated constantly as the order moves through the pick, pack, loading, and goods issue process. So this ODO is the working document against which we're going to be processing all the warehouse activities. So now we need to create warehouse tasks for picking the required quantity from the source storage bins. The system has identified the source bins through the configuration of storage type searches and stock removal rules according to the warehouse-specific data stored in the warehouse product masters. And note that the creation of these tasks can be automated. It's shown here in foreground mode just for the purposes of the demonstration. Now this is the EWM Warehouse Management Monitor screen, which helps to display the current status of the outbound delivery order. We can see that the system has determined that 2 picking tasks are part of the overall outbound process, and they're labeled as OB01 steps in the lower right part of the screen. And the destination for the materials is a packing work center. Now the next step is to access the created tasks on the RF terminals and confirm them as the picks are completed. So here we can see a menu path on the RF device that would allow the warehouse user to search for open warehouse tasks using the system-guided method. We select the outbound queue, and the system gives us the next task in the queue that needs to be processed. We aren't going to be using a pick handling unit in this case, so we're just going to proceed to the next screen. The 2 picking tasks are presented in the order in which they should be picked. Here you can see that the source storage bin and the product ID need to be scanned into the verification fields on the screens to verify that we're picking the right materials from the right locations. We also have to verify the quantity picked by typing it in. All of these verification fields are configurable, so you can set it up to require verification on as many or as few of these fields as you want. For the second pick, you can see that there is a destination handling unit. This is because this is the last material to be removed from this bin, and it's on a handling unit. That bin will become empty when I remove the material, so I need to remove the pallet as well. Because I'm causing one of the storage bins to become empty, the system is requiring me to perform a low stock check based on the configuration for physical inventory in this EWM warehouse. So I'm submitting an empty bin function. And then I'm required to verify the placement of the picked materials into the packing work center. So this completes the execution of the picking tasks. The material that has been picked has been moved to the packing area. If there were any more open picking tasks in the outbound queue, they would be presented next, but there aren't, so I'm back at that initial screen. So this is the packing screen where we can record how the picked items are going to be packaged up for loading onto an outbound vehicle or trailer. The picked items appear in the left side of the screen, and on the right side we can use the provided functions for creating new handling units to pack the items into. Here's the same screen again, but now we've repacked the 2 picked items into a single handling unit, which represents a shipping box. At this point, I would generate and apply a label to the box and possibly a packing slip or some other documentation that needs to be inserted or attached to the box. And the last thing we have to do on the packing screen is to close the handling unit. And when we close the handling unit, we're indicating to the system that the packing activity has been completed for this order. Looking again at the warehouse monitor, we can see that the tasks for this outbound delivery order have been updated. For the picking activity, we can see the original 2 picking tasks, and the execution of those tasks on the RF screens move the materials from the source bins to a handling unit belonging to an EWM resource named D. Scott, which was me. And there's a third task representing the movement of this handling unit and its contents to the packing work center. Then we can see a task labeled as OB02, which was posted automatically in the system as a record of the completion of the packing activity. And finally, there's a third task, which is labeled as OB03, and it's in open status. And this was created automatically by the completion of the packing activity. And it means that the handling unit needs to be moved out of the packing work center and into the goods issue staging area prior to loading. So the next activity is to confirm the staging of the packed handling units for loading. We can process this movement on the EWM RF screens, and I'm navigating to the screen using a standard RF menu path. So I can select by handling unit number, since I already know the HU number. It would be present most likely in a barcode format on a label that I printed from the packing screen. So I start by entering or scanning in that HU number, and then I scan the required verification fields. And again, these verification fields are configurable, and depending on the scenario, it might not be necessary to do all of these scans. The destination screen shows me where to place the handling unit, and then I'm returned back to the initial screen. That pallet has now been moved to the staging area, and the next step is to load the pallet onto an outbound delivery vehicle. Before I can load the handling unit, we need something to load it onto. So first thing I have to do is create a transportation unit, or TU. This could represent, for example, a trailer onto which many pallets can be loaded. And in this screen, we can also see the assignment of our outbound delivery order number, 6313, to this transportation unit. I need to check in the transportation unit into the yard before I can load it. So we use an EWM check-in, check-out transaction to record this check-in. Here you can see the TU has arrived at the south checkpoint, which is the entry point into our yard management system. We can then post a movement of the TU to a warehouse door when loading is ready to begin. And here you can see the source for the movement is the south checkpoint, and the destination is the south door, which is connected to door number 2 in the warehouse. So once this TU is assigned to the dock door, we can begin loading things onto it. So our next step is to load the handling units that were staged earlier onto the transportation unit. And this action creates and confirms a warehouse task in EWM for loading against the ODO. We can access the transaction using the RF menu as shown here. We can scan each handling unit to be loaded and confirm the movement into the destination bin designated for goods issues for outbound delivery orders. And once all the HUs are loaded, we can return to the ODO document to see the changes that have been made. So in this demo, we only have one handling unit to load. So looking again at the warehouse management monitor, we can see that the loading status has now been updated to completed for this outbound delivery order, and the status for all of the outbound steps at the lower right has been set to C for completed. From a shipping standpoint, we need to close out the transportation unit by setting its loading status to complete, as shown here. And then we need to move the transportation unit back to the checkpoint. This takes the form of a simple warehouse task in EWM, moving the TU from the dock door to a checkpoint storage bin. We can use the same check-in, check-out transaction to record the departure of the transportation unit from the yard. And in this scenario, I've got it configured so that the goods issue is posted automatically for all the outbound delivery orders contained in a transportation unit when it's checked out. So one final look at the outbound delivery order using the WM monitor. We can see that the goods issue status has been updated to completed. And again, that was accomplished by checking out the trailer that the ODO was loaded onto. Now I'm just showing the originating document, which was the outbound delivery in the ERP system. It's been updated as a result of the goods issue posting in EWM. On this screen, we can see that the goods issue has been posted, and this update happened in the background thanks to the a queued RFC call from the EWM system. As well, the details of the TU, which was created in EWM, have been synchronized with the data in the ERP delivery document. You can see the TU number has been populated into the Transportation ID field in the Shipment tab of the delivery header. And finally, the delivery was also updated with the packing details. We packed the delivery in EWM, and you can see the handling unit that we created in EWM. It's now in the packing screen on the ERP side in the delivery. So this brings us to the end of the demo. I have a few more slides to highlight some additional functionality that can be optionally worked into your outbound process in the EWM system. I'm going to quickly run through these next 4 or 5 slides. I've already shown you some of the yard management functionality in the demo. Yard management functionality is built right in, as we've seen, to the EWM system. You can activate it or deactivate it for each EWM warehouse at your discretion. Basically, this functionality gives you the ability to monitor and manage vehicles, trailers, and other means of transporting materials from checking in at the entry point to your yard, between parking spaces within your yard, and right through to the checking out of the vehicles from your yard. Because the yard management component is built right into EWM, it shares many of the same structural components. For example, the doors, parking spaces, and checkpoints. Those are all modeled using storage types, storage sections, and storage bins. The yard management doors are directly linked through master data through to the warehouse doors in EWM to facilitate the loading of materials from the warehouse into the TUs. One thing that we really didn't see in the demo is the ability to monitor the yard using the WM monitor. So you can use the WM monitor to keep track of the vehicles and trailers that are currently in your yard. You can look at doors that are empty or occupied. And you can also look up warehouse stock that's currently in the yard. Resource management is integrated into EWM. If you wanted this type of functionality within ERP WM, you would have needed to implement the TRM component of the LES software. Resource management basically consists of resource control, queue management, and task interleaving. So when you put all this together, along with the inherent monitoring capabilities for resource management, you have a really great tool set to help you manage a complex resource situation with regards to picking, packing, and shipping. Labor management allows you to plan and measure labor times for warehouse resources. And the outbound process is just one area where labor management can be applied. It's intended to be used across all your warehouse processes. Labor management gives you the ability to define and use engineered labor standards so that you can calculate planned and actual workload volumes. If you have engineered labor standards already defined in another legacy system, you can upload them into EWM using standard programs and data structures. So the system can be used to track direct labor for activities like picking and packing, and also indirect labor such as cleaning, maintenance, and meetings. You can also track non-productive time such as breaks. So EWM lets you define these activity types, and warehouse users can enter their time against these activity types in standard RF or desktop screens. EWM supports a variety of cross-docking functionalities and methods. Generally speaking, these methods are grouped into planned cross-docking options, where the cross-dock decision is made before the goods arrive, and opportunistic cross-docking, where the cross-dock decision is made at the time of goods receipt. So the idea with either method is to reduce extra handling of materials by matching inbound materials to outbound documents without ever having to put the goods away in the warehouse. Finally, batch management is very important to companies in certain industries such as pharmaceutical, chemical, and other process industries, where it's important to track materials by lot numbers. Typically, batch master data is managed within the ERP system and distributed to EWM, but it's also possible to create new batch master data in the EWM system, and these batches are communicated back to ERP. EWM provides the ability to use documentary batches. When you use documentary batches, the batch number is required to be entered within various goods receipt and goods issue transactions, but the inventory itself is not managed with batch numbers. And that's a functionality that's unique to EWM. It's something you can't do in the ERP WM system. Finally, the functionality for serial numbers is much more flexible and robust in EWM as compared to ERP WM. Serial numbers are typically used for materials that are very expensive, or maybe for warranty purposes or some other reason, whatever reason they need to be tracked individually. So we have several options available for tracking serial numbers. We can allow serial numbers to be entered. We can require serial numbers to be entered, and also we can manage the warehouse stocks right down to the bin level using serial numbers. And of course, different materials can be defined to be managed in different ways with respect to serial numbers. In the outbound process, serial numbers can be specified in the ERP outbound delivery, or they can be entered against the outbound delivery order in EWM while confirming the picks. And finally, there's an EWM option for the creation of provisional serial numbers, which are temporary or placeholder serial numbers to allow you to get the goods into the warehouse even before you actually know the precise serial numbers. And then once the actual serial numbers are known, you need to replace the provisional numbers with the actual ones. And again, that's something that's unique to EWM, not present in ERP WM. Okay, so we've reached the final part of the agenda, and we're running a little late. To help me with the questions and answers, I'm going to ask my colleague Kyle Sorensen, who's the Director for SAP Solutions with Logistar, to join us.
Great. Thank you, Doug. Welcome, everybody. We have quite a few questions that were coming in, so I was trying to organize them. If we don't get, well, I know we won't get to answer all of them, but we will follow up with you on your submissions that we did not answer here. So first of all, and I can help answer some of these, Doug, as these have been coming in. One of them is, does the status get communicated back to ERP as the EWM, I think it says as the EWM processes and outbound delivery? The answer is yes and no. So number one, if you're using the yard management functionality, when you check, for example, that trailer is in the plant or is in your yard, that will send an update to ERP to say it's in plant. And then when you've completed your activities and done the post goods issue, then it will send something back to ERP saying this is completed. But to check like the active processing, like I'm in the process of picking this delivery, you have to get that information from EWM, not in ERP. Another question was, can you create warehouse orders to a pick face, even if there are already enough current tasks that will empty the pick face? Because in current WM, it would go to another storage type to satisfy the pick request. The answer is it can be set up to drive a storage type negative, so you could essentially send a task to overpick a location, such as like a planned replenishment that you will be doing a replenishment from that location. But if you do not set that option, then it will work as standard ERP WM works, in that it'll send you to a different location to pick. Another question was, during the low bin quantity or zero quantity check, if the quantity is incorrect, it needs to be adjusted, and there are open transfer orders or warehouse tasks for that bin, how is the quantity adjusted? Basically every type of counting method, which is such as cycle counting or physical inventory or even these low stock checks within EWM, they all leverage what's called dynamic cycle counting. It was a 4.7 extension 2 option that was added into ERP. Essentially what that does is it understands the tasks that are open going to and from a location. So whatever quantity that you're saying is in there, SAP is going to look and understand, oh, is there a pick from here too? And then it will adjust the quantity appropriately. Hopefully that answers that question. Unfortunately, we are running right up to the timeline here, so we will get back to the questions that we were not able to answer. Apologize for that. But please feel free to send any follow-up questions to the email on the screen. Today's slides will also be sent to you within the next day, along with a link where you can download a copy of today's webinar on demand. So on behalf of Logistar Solutions, I want to thank you for attending the webinar today. Hopefully we'll see you on part 3 of our series, and to learn about Harry and David and how they replaced their best-of-breed applications with the SAP Extended Warehouse Management. So the invites will be sent out soon, so make sure you sign up. Again, thank you for your time, and have a great day.